For this problem, we're trying to find the angular velocity of the diver when he leaves the diving board. So for this problem, we know that I1 is the rotational inertia of the diver when he is in the straight position, and I2 is the rotational inertia of the diver when he is in the truck. Now this is just the conservation of angular momentum formula, and we're going to rearrange it to this. Now we also know that from the problem that the rotational inertia decreases by a factor of 3 when he goes from the straight to the tuck position. So we know if we divide it by 3, that will decrease it by a factor of 3. So down here we know that given that when he is in tuck position, the angular velocity of the diver is 2 rotations in 1.33 seconds, which we get from the problem too. So basically we just set up the angular velocity when he's in the tuck, because we know that this is the angular momentum when he's in the tuck position, so this would be the angular velocity when he's in the tuck position, and we're trying to solve for the angular velocity when he's in the straight position when he leaves the diving board. So we basically just arrange, since we already rearranged it before, and we get W2 equal, or not W, angular velocity in the tuck position is equal to 9.45 radians a second. Now all we have to do then is input into our angular velocity formula that we created up here for the straight position. So if you can see here, we know that I2 is equal to I1 over 3 because it decreases by a factor of 3, and we have the equation that we arranged up here. So we basically just plug this into the top, which we get I1 over 3, and then we have I1 on the bottom, as you can see, it's the same. And then we have the angular velocity for the tuck position, which we found here, and we plug that in, and it gives us the angular velocity of the diver in the straight position is 3.15 radians a second.